covalent bonds. Okay, and I'm also going to add. So what we're going to talk. So let me take a step back. What we're going to talk about in here is again covalent bonds, how to find polarity, and then I want to talk about metallic bonds. There will be a third video because I can't figure out how to put it on here, but it is going to be on this how to do Lewis dot structures again and line dot structures. Okay, and then we'll get into another video after that. So, excuse me. The covalent bonds, again, they're going to share electrons. Now, if it's nonpolar, they're going to share it equally. If it's polar, they're going to share it unequally. And if it's ionic, of course, they're going to transfer. So that's why I put it up here. So let's talk about polarity, and then I'll get into metallic bonds. So that's where we're at. Okay, so polarity, you're going to have an electronegativity. If you remember on our periodic table, electronegativity goes to fluorine, and fluorine is has the greatest electronegativity. Okay, I'm going to pull up my chart real quick. My computer keeps dying on me. So what we're doing, how do we find the polarity? Well, we take the differences between the electronegativities. Okay, I keep losing my thing here. Hold on. Sorry. Okay, so what do we do? So if I'm going to have two hydrogens together, I have hydrogen bonding with a hydrogen. So we're going to look on our chart. Hydrogen has a 2.1 electronegativity, and this one has a 2.1 electronegativity. So what we're going to do to find polarity, either it's nonpolar, polar, or ionic, is we're going to find the difference between these two. So basically, you take 2.1 minus 2.1, and you get a 0.0. Well, 0.0 falls under nonpolar. So this bond, or this molecule, is nonpolar. Okay, now I'm going to put a word up here because I keep forgetting to put this up here. Molecule. Write this down. A molecule is no, I can't draw. I'm drawing a blank. But molecule is two atoms. Give me a second. I have it up here. I'm drawing such a blank here. Okay, so every combination of atoms is a molecule. A compound is a molecule made up of atoms from different elements. All compounds are molecules. Okay, so there's another word, compound. Okay, so all compounds are molecules, but all molecules are not compounds. Okay, so how does this happen? A molecule is formed when two or more atoms of an element combine together. So that's that. But when they only consist of one type of atom like this one, this is only a molecule, not a compound. Okay? So this is a molecule, not a compound. All right. So make sure you have those two words in your journal and put your own definition to it. But all compounds are molecules, but not all molecules are compounds. Okay? And in that case, molecules of the same element are not compounds. Okay, so let's do another one. Let me go back to my other one here. Let's take carbon and fluorine. Okay, remember the Lewis dot structure for this we did in the last video, and it looked like this. Where we had 8 dots around the fluorine and 8 dots around each carbon. Okay, now our electronegativity for these, and I gotta find my electronegativity chart again. Okay, so carbon is 2.5 and fluorine is 4.0. Okay, 4.0. So how do we find out if it's polar, nonpolar, or covalent? I think something's wrong here. I'm thinking this is 1.7. I think I might have this wrong. So fix this. It is 1.7. I knew I said something wrong. It didn't look right earlier. 1.5 is our difference because we're going to subtract them. 1.5 is a polar covalent bond. How do I know it's covalent? Because there's no metallics in here. Each one of them are nonmetals. Okay, so that's how I knew it was something was wrong. So please change your polar and ionics to 1.7. Okay, in your notes. So I apologize for that. In the last video I had it as 1.4, but I just changed it. So make sure you have it on there, and I'll have it on your stuff at school. Okay, so that's how you find polar versus non-polar. Okay, now let's talk real quickly about metallic bonds, and then I'll cut this video off and we'll do another video for the next part of it because it'll get too long otherwise. So metallic bonds are simply this. All you need to remember about metallic bond is that it is a C, let me put this one, C of electrons. C of electrons. What is this? What are some properties of this? They become malleable. They are ductile. And they're good conductors. Because what's happening is these electrons, there's a sea of electrons, okay, when they bond together, and they flow past each other, and they create a good malleability. They kind of squish together when we pound them. They are stretched, and then they are good conductors of electricity. So just remember C of electrons for metallic, okay? And I'll see you guys in the next video.